everyone, welcome back to the AWS Cloud and DevOps Hands-on Implementation Series. This is the episode 11 and in today's session is absolutely foundation. We will cover some basic and essential Linux and Git commands for cloud engineers, then real demos on EC2 instances, then core DevOps philosophy, the SDLC versus DevOps lifecycle, CI/CD pipelines and automation tools. I will explain each command and concept with real use cases and show you what result to expect. If you are aiming for a cloud or DevOps job, this is your solid starting point. So let's get started. Let's start with the Git, the backbone of version control. Every DevOps or cloud project you work on will use Git in some form, especially through GitHub, GitLab or Bitbucket. Whether you are managing application code or infrastructure as a code like Terraform script or CloudFormation template, Git is your best friend. So what exactly is Git? Git is a distributed version control system. That means instead of one central repository where everything lives, every developer has a full copy of the entire project, including the full history. This gives superpowers like working offline, creating your own branches without affecting others, then merging code changes easily, then rolling back to the previous version if something breaks. Now let's look at the real DevOps use cases. So version control for application source code like in language Node.js, Python, Java or anything. Then tracking changes in your infrastructure using tools like Terraform or CloudFormation. Then triggering automated CI/CD pipelines using tools like Jenkins, GitHub Actions or AWS CodePipeline. Alright, let's jump into the most essential Git commands you will use daily. I will show you the terminal side by side for each one. So first of all command is git init. So there is one software git bash. So open the software git bash. In git bash first of all we will create one folder. Command is mkdir cloud practice. Enter. Then go to that folder. Enter. Now we will create one text file there. Command is search file.txt. Enter. Then now we will use git command. First of all, first command is git init. So this command initialize a new git repository in your current directory. So git initialize a empty git repository. Then command is git status. So this tells you what's going on, whether files are modified, untracked or staged. It will show the status of your files. So it is untracked file. Then the next command is git add dot. Dot means it will add all the files which are unstaged. Enter. Then this stages a file. You are telling it that I want to include this in the next commit. You can also use a file name also git add file.txt to stage everything. Then next command is git commit -m initial. Here you can write any message. Enter. Commit this stage files means the message should briefly describe what changes. Always write a meaningful commit message like added login validation, created this file or something like that. Then next command is git log. It will show you your commit history with author, timestamp and commit messages. Author name Sagarika, then date and this message initial commit. Then next the command is git clone. Git clone space you can write any repository id, so you can clone to work on this file. Then the command is git push. This send your local commits to the remote repo like GitHub, Bitbucket or any. Then git pull, it fetches and merges the changes from the remote repo to your local code base. So git push origin main, git pull origin main. Using pull we can pull the code from another remote repo, or from git push we will send our local commits to remote repo. Use origin to refer the default remote and main as the branch name. So now you have seen Git in action. It's not just for code. In DevOps, Git is how teams collaborate, track the changes, and automate the deployment. Knowing this command is your first step to become cloud native. So these are some basic commands. Commands are git init, git clone, git status, git add dot, git commit -m, then git push origin main, git pull, and git log. So always remember this basic step. Now, talking about Linux, Linux is the backbone of the cloud. Whether you are launching an EC2 instance on AWS or deploying instance on AWS or then containers, you are almost always interact with the Linux system. Common Linux system include Amazon Linux, Ubuntu, CentOS, and then they all share the same core commands. Now, let's understand how Linux organize the thing. Everything in a Linux is a file, whether it is text file, devices, even running processes. The file system is structured hierarchically like a tree starting from the root. You will spend a lot of time navigating this structure while troubleshooting, configuring servers, or automating tasks. Now let's open a terminal inside a cloud instance like EC2 and go through some essential Linux command. For that we need to create one EC2 instance, then we will demonstrate how Linux commands are used. So go back to the AWS console and create your EC2 instance. Now I have created the instance and connected through SSH. Now we will demonstrate some commands. So first command is pwd. It print a working directory, means it shows where you are right now in the file system. It prints /home/ec2-user. Then next command is ls hyphen al. So it lists everything in the current folder, including hidden files with permission, size, owner, and timestamp. It is great for checking which file exists and who can access them. You can see the permission, date. Then next command is mkdir demo folder, enter. So it makes the directory. It create a new folder called demo folder. Then command is cd demo folder. So it changes the directory, means move inside that folder. Now the command is touch readme.md, enter. It create an empty file, means it quickly makes a blank file, common for starting documentation or script. Then command is echo hello world. Readme.md, enter. So what it does, it writes the hello world into the file. If the file exists, it's overwrite it. Then next command is cat readme.md. It views the file content, it displays the file content right in the terminal. So you can see here hello world, which we have written from above command. So these are some basic commands of the Linux system, means creating folders and then writing inside that file, permissions. About permission, I will show next. These are go-to commands when working inside any Linux-based cloud instance, whether you are checking logs, deploying code, or debugging error. These basics are from the foundations. Other commands are also rm. It removes the file, then it clears the terminal, then echo, which print the text, and then man is for manual pages. Now talking about permission and package management. So security in Linux starts with the file permission. They define who can access what. Whether you are securing your config files or deploying a shell script, understanding permission is critical. So every file in a Linux has three key components: owner, group, and permission. Owner is usually the user who created the file. Then group is the user who share access under a group name. And then talking about permissions, control what the owner, group, and others can do. This under permissions. So permission are shown as RWX. R is for read, means for viewing content. Then W is for write, edit, or delete purpose. Then X is execute. It run as a script or program. So then owner means EC2 user can read, write, or file. Then group can read, others can read. There are some numeric notation simplifies the permission. 7 equal to RWX means it has permission to read, write, and execute. Then 6 is for RW. Then 5 is for R-X. Then 0, no access. We will often see the commands using chmod 755, chmod 600. These numbers define access for owners, group, and others. Now go to the terminal. Now type command chmod chmod 700 readme.md. Enter. So now the file is fully private to the owner from this command. Then type ls-l readme.md. So you can see /rwx ec2 user and date. So this is the as the output. Then the command is sudo chown ec2 user ec2 user readme.md. Enter. It changes the ownership to a specific user and the group from this command. Useful when uploading files or switching. So use this command when managing deployment scripts or securing sensitive files like SSH keys, environment variables, and logs. Getting file permission wrong can lead to the broken apps or security risks. So for permission, chmod, chol, sudo grant and manage the access right. Then apt update, apt install nginx or em install will manage the software and install the required software. Then systemctl start nginx, it will start our nginx server. Then there are command kill monitors. Then top. These are Linux basic commands. Let's now zoom out and look at the big picture DevOps. It's not just about tools like Jenkins or Docker. It's a culture and a practice that reshape how teams build and ship the software. DevOps means development plus operation. Traditionally, developers wrote the code, handed it over to the testers, and finally to operation for deployment, often with delays and miscommunication. DevOps break these layers, encouraging shared responsibility, collaboration between the development QA and operation specialists, automation across the life cycle means build, test, release, and then monitor. So main concept are continuous integration means CI. It automatically integrate the code changes. Then continuous delivery or deployment means CD. It release the code faster and reliably. Instead of working in isolated steps, teams work together with shared goals and feedback loops. Key benefits of DevOps are faster software release means it automate the pipelines and collaboration reduce the delays. Then it improves the reliability means infrastructure as a code, version control and monitoring reduce the risk. Then quick rollback, version deployment allow easy rewards if something breaks. Then team ownership, developers are now part of the operation from writing code to maintaining the uptimes. Test early, fixed early. In DevOps, testing happens closer to the development to each catches bugs sooner. Encourage small, quick experiment and learn from the failure quickly. Using code means like Terraform or CloudFormation to provision the infrastructure. Then CI/CD pipelines are automate the process from code push to the deployment using the tools like Jenkins, GitHub Actions or AWS CodePipeline. So DevOps is the foundation of modern software delivery. Every tool we explore, Git, Linux, Jenkins, EC2, S3 files into this larger puzzle. It's all about building faster, safer and smarter. So talking about traditional SDLC and DevOps lifecycle, SDLC stands for Software Development Lifecycle. Its phases include requirement, design, code, then test, then deploy and then maintain. How it works? Let's say a company is building a food delivery app. Requirements are a business analyst write down what the app should do, then designers and architect plan the layout and the structure, then developer write the code after the design is finalized, then QA team test the app after all code is completed, then operation deploy the app to the production. Then bug fixes are made after user completes. So problems in this are if tester find a bug, the developer who wrote it may have moved to the another task. Fixing issues late causes the delays and then user may wait months for new features or improvement. Real world analogy is like building a car from the scratch and only testing if the drives after assembling the entire vehicle. If something wrong, you take it part again. Now, DevOps lifecycle phases are in the loop, means plan, then develop, then build, test, release, deploy, operate, then monitor, and then feedback. How it works? Now, imagine the same food delivery app using the DevOps. First, plan and develop. Developers and tester collaborate on a new feature like adding digital wallets. Then build and test. The code is automatically tested with every change using Jenkins or GitHub Action. Then release and deploy. If test pass, code is automatically deployed using a pipeline in CI/CD. Then logs and matrices using CloudWatch or data log show performance and the errors. Then feedback, user behavior and the bugs report are reviewed weekly for improvements. Benefits are bugs are caught early, features are delivered weekly instead of quarterly. All teams stay involved throughout the process. Real world analogies like running a restaurant kitchen. Chef, waiter, and dishwasher work together continuously, constantly improving the dishes based on the customer's feedback. So, in summary, SDLC is a sequential, means waterfall. DevOps is the continuous, means loop. Then team structure is celluloid, and in DevOps it is a collaborative. SDLC speed is slow, months per update. Then DevOps is fast, daily or weekly releases. Feedbacks are delays in SDLC, and feedback is continuous in DevOps. Example tools for SDLC are manual testing, FTP, and in DevOps CI/CD, Git, Jenkins, and Cloud. Let's now discuss CI/CD, the heart of DevOps automation. CI stands for continuous integration. What it means? Developer works on different features or fixes in parallel. They frequently merge their code changes, often daily, into a shared repo. Then every time code is merged, automated builds and test runs. Why it matters? It catches the bugs early, ensure the code base is always in a deployable state. Imagine 5 developers working on a banking app. Every time one of them pushes the code, Jenkins automatically pulls the latest code, compiles the application, run unit test, and then send result on a Slack. Popular tools for are Jenkins, GitHub Actions, Circle CI, Travis CI. Then, like a safety scanner at an airport that check every bag right as is added, problems are caught before boarding, means deployment. This is a real world analogy. Then talking about CD, CD stand for continuous delivery. After successfully testing in CI, the code is automatically packed and prepared for deployment to a staging or production environment. Deployment require manual approval. For example, a manager clicks on deploy. Why it matters? It reduces the time between the writing code and releasing it, adds a safety checkpoint for critical safety. For example, after CI passes, the build is sent to the AWS code deploy and a release manager approve it before pushing to the production. Then another term CDs. CD also stand for continuous deployment. So what is mean? It takes the continuous delivery further by automatically deploying to the production without manual approval. High confidence in test is a must. Why it matter? It enable truly agile and rapid delivery. New features or fixes go live within the minutes of merging. For example, a startup shopping app deploys a new feature to the production automatically after passing all tests, no human intervention. A real world analogy is like a conveyor belt that auto packs and delivers the product to the customer, provided sensor confirm the items and correct and safe. So CI/CD tool chains are CI means build and test, tools are Jenkins, GitHub Actions, and CD delivery means continuous delivery, Jenkins pipelines or AWS CodePipeline. Then CD deployment, AWS code deploy, Agro CD, GitLab CI/CD. Then for containerization, Dockers and Kubernetes. This pipeline ensure your app is always production ready, tested, packaged, and ready to ship at the click of button or no click at all. So that's all about CI/CD. It is the engine of DevOps. Main terms are CI, continuous integration, continuous delivery, deployment benefits. It faster releases, early bug detection, and reduce the manual intervention. So these are the tools of the trade, means Jenkins, GitHub, Docker, AWS CodePipeline, and Terraform. I will tell you CI/CD workflow with DevOps tools. First of all, Git plus GitHub. Code is version control and the stored. Then Jenkins pull the code, run the test, and build the app. Docker package app into the containers. Then Terraform provision the cloud infrastructure. Then AWS pipeline, it automates the deployment to the AWS. Flow is GitHub, Jenkins, Docker, then Terraform, then CodePipeline, then AWS. Alright, let's wrap up today's video with a summary and a quick look at what's coming next. So what you learned today? First one, Linux command. You learn how to navigate cloud instance using essential commands like pwd, ls, cd, mkdi and more. Then you know understand how Linux secures file using permissions with rwx and how to manage ownership with chmod and chown. Then you explore version control using Git, from initializing a repo to pushing code to GitHub, a critical DevOps skill. Then you created your first script and made it executable, a powerful way to automate repetitive tasks. Then you learn how DevOps blends development and operation to promote collaboration, speed and automation. You now understand the difference between CI/CD and means continuous integration, continuous delivery, and continuous deployment. Plus, how tools like GitHub, Docker, Terraform, and AWS CodePipeline work together to automate this lifecycle. In the next episode, we will build a complete CI/CD pipeline on AWS using GitHub as a source repo, AWS code build to compile and test the code, AWS code pipeline to automate the flow, then EC2 as a deployment target, notification via SNS or email. You will see how your code moves from GitHub to production without manual setup or using native AWS services. Thanks for watching this foundational video. If you found this helpful, like, share and subscribe. And I will see you in the episode 12 where you go fully hands-on with AWS native CI/CD. Thanks for watching. Happy learning.